Memory profiling using NetBeans profiler. So here we are going to talk about memory profiling features of NetBeans, and then we are going to talk about live memory profiling, and we are going to learn the concept of generation count, which is used to detect memory leak, and we'll talk about heap worker feature that comes with the NetBeans profiler, and dynamic attach. Memory profiling features of NetBeans. So by using NetBeans profiler, you can track down memory leaks on running application, and you can actually see allocations on the heap on these running applications. It provides memory usage patterns, so you can detect memory leak even when the memory leak is very small. Okay, so you can actually see the pattern to detect where memory leak is happening. NetBeans provides heap worker, so this is used to analyze a heap dump that was created. So you can actually use a heap worker to quickly identify memory leak as well. So basically, if you happen to have some kind of memory dump that was created because of out of memory situation, then you can use a heap worker to find out where memory leak is happening. Okay. It lets you figure out why a particular object is not being garbage collected by the JVM, which means there are some objects referencing other objects, and that those other objects are not being garbage collected because they are being pointed or referenced by other objects. We are going to actually use Eclipse Memory Analyzer in our next topic, and Eclipse Memory Analyzer is actually considered more powerful heap worker than NetBeans heap worker, however. So we're going to use both. So how does NetBeans profiler work? It does use what is called bytecode instrumentation. It's actually using two schemes, sampling and bytecode instrumentation. So we're going to actually focus on bytecode instrumentation on this slide. So bytecode instrumentation is a technique for adding bytecode to the Java classes during runtime. So the code is being added to the Java classes runtime. So it basically is like a filter. It actually captures the beginning of the call, and it intercepts the beginning of the call, and then do something to measure the duration of the call and memory usage and things like that. In order to use the NetBeans profiler, you have to perform calibrating JDK. You have to basically calibrating JDK is to measure. So let me actually use these bullet points. Instrumenting bytecode on a running application imposes some overhead. Okay? So by calibrating JDK, you can actually figure out how much overhead is actually being imposed. Okay, so to guarantee high accuracy of profiling results, NetBeans profiler needs to collect calibration data on a JDK in order to factor out this overhead spent on code instrumentation. Okay. So you need to run the calibration process for each JDK you will be using for profiling. Okay, so if you happen to have multiple JDKs and if you are running your applications on those JDKs, each of those JDK need to be calibrated. Okay. Calibration data for each JDK will be saved in the home directory under .mb profile. All right, so we are going to do our first exercise. So here we are going to actually perform calibration on your JDK. Okay. So let's take a look at the lab documentation. Okay, I have a lab documentation here. For those of you who are taking JPassion.com for the first time, basically you are going to download this hands-on lab zip file, and then you're going to unzip it. Okay, and once you unzip it, in this case, it will create what is called the memory underscore profiler directory, and you basically read. So this is the directory that gets created, memory underscore MB profiler, and you want to read this index file. That is the lab documentation. So we are going to use this lab documentation. Okay. All right, so first exercise is perform JDK calibration. Right? So first of all, you have to download and install NetBeans. Okay, so I assume you have done that, or I'll give you some time to do that if you have not done so yet. And then we're going to actually move on to calibration. So here, basically, you are going to select profile and advanced commands. And then you're going to select the JDK for calibration. Yeah, so this is actually captured using NetBeans 7. NetBeans 8 has a little bit different UI, so let me just show you. So select profile and advanced commands and manage calibration data. And you might in fact have a multiple JDK. So I have a JDK 1.8, which is the default. Okay, so I have already done the calibration. So last calibrated January 18, 2015, which is I've done yesterday. So in your case, if you have not performed any calibration, it will say not calibrated. Okay, and then you click calibrate. Okay, then it will be calibrated. So this is actually one-time deal, so you don't have to do it anymore. Okay, so once you've done the calibration, you should be all set. Okay. All right, so I'm going to give you guys a few minutes to try this exercise. So we're going to actually move on to live memory profiling. So this is the picture that shows live results. So as you can see the types of Java classes. So the live bytes, live. So this is not full name. One is the percentage, the other one is the number of objects and things like that. And the last column is generation count. Okay, so this is something we are going to actually do in the hands-on lab. So there are a few important columns that you want to actually observe in the live results once you perform memory profiling. Allocated objects, so it's the number of objects that the profiler is monitoring. This includes live objects and non-live objects. Okay, now the live objects are the number of allocated objects that are still in JVM's heap and therefore taking up memory space. Okay, so these are the objects that are not yet garbage collected. Okay. The average age, that column shows the age of each live object. The age of each live object is the number of garbage collections that it has survived. So average age is computed as the number of live objects. So basically the sum of the ages of all objects divided by the number of live objects is considered as is computed as the average age. Okay, so age of each object is the number of garbage collections that it has survived. Okay. Now, the last important the concept is generation count. In fact, we are going to learn this concept in a bit more detail in the following slide. So generations count is the number of different ages for live object. Okay, so let's talk about that concept in a bit more detail. Generations count. So generation counts is in fact used for detecting memory leak. So generations count, as we talked about in the previous slide, is the number of different ages for live object. Okay, and we're going to actually use more pictures in the following slide to understand this concept. So if generation counts keeps increasing, it indicates that new objects are being created while old objects are still in memory. Okay, so it indicates a memory leak is happening. Okay, because objects are not being garbage collected. Now, a typical Java application will have a long-lived object and short-lived object. So long-lived objects are created at the beginning and stay alive for a long time. Okay, for example, if you want to create large array in the beginning of the application, and if that the array should stay live until the application shuts down, that array is considered as a long-lived object. And short-lived object, the objects that gets created and destroyed in a short duration. Okay, so typically, even before these short-lived objects should be created and destroyed within a single garbage collection period. Okay, so let's talk about the generation counts for long-lived objects. So we're going to actually take a look at the two healthy behaviors and one memory leaking behavior. So this is the healthy behavior for long-lived object. Okay, so in the beginning of the application, we have 3 objects that are created. Okay, and then we have 7 garbage collections occurred. So each of these objects will have an age of 7. Okay, so each of these objects has age of 7 because they survived 7 garbage collections. Okay, now what is the generation count in this case? The generation count in this case is 1 because, as we talked about, generation count is, if you go back here, is a number of different ages for live objects. Okay, so in this case, the number of age is just 7. So there, there is the generation count is 1 because the only age is 7. Okay, so this is healthy behavior. Okay, so there is no memory leaking happening. Now this is another healthy behavior. So this is for short-lived objects. So short-lived object is actually, basically the object gets created and then destroyed before the next garbage collection, and that is good. Okay, so there is no memory leaking. So again, this case, generation count remains 1 because in this case we have an object, and because it didn't survive, it doesn't actually have any garbage collection. The age is 0. Okay, again, the generation count is a number of different ages, right? So there is only one age, which is 0. So in our previous case, there is only one age, which is 7. And so generation count is 1 in this case. And the same thing here, generation count is 1. Okay, because the only age we have is 0. Okay, so in both cases, there is no memory leaking happening. Okay. Now, the third case, this is where memory leaking is happening, and you can see it has higher number of generation count. Okay, so it's unhealthy behavior because memory leaking is happening. So we have initially allocated long-lived objects, okay, which survived the 7 garbage collections. So that's, their age is 7. Okay, now this object gets created and then it stays there and it survived the 6 garbage collections. So the age of this is 6, and the age of this object is 5, and 4, 3, 2, 1, and things like that. And and this object gets created, and it didn't have any garbage collection. The age is 0. So in this case, generation count is generation count is 8. Okay, because we have 8 different ages. Okay, so age 0, age 1, age 2, age 3, age 4, and age 5, and 6 and 7. Excuse me. So in this case, you can see objects are not being garbage collected. Okay, so if you have a generation count keep increasing, that is a strong indication that memory leak is happening. Make sense? All right, so let's do exercise 1 and 2. So we are going to do exercise 1. So we are going to open memory leak web sample application, which is located under samples NetBeans directory. So this project are provided in both Maven or NetBeans, the project. Okay, so you can actually open either of those. So we can actually open on the samples NetBeans directory. Okay, so you can take a look at the code. So let me actually show you. So I have already opened that code, memory leak up here. And if you take a look at the source code, okay, you can see we have this code in which memory leak is happening. So what happens is that we are in a while loop, okay, and stub is false, so this is always true, and we are basically creating 2 array objects. One is the array of float, and the other one is the array of double. And then we are basically adding those two objects into this map. Okay, so eventually memory leak is going to occur. Okay, because these two objects, this flow array object and double array object, they are not going to be garbage collected because they are referenced in this map object. Okay, all right. And if you take a look at the code, this is, by the way, web application. So this memory leak, this is the servlet code. And so let's actually run this code. Let me just show you how it runs. So right click and run it. And we are going to run it over Tomcat. Okay, so if you click start leaking, it will leak. It will actually cause. So if you click the start button, it will run this leak. Leak is actually this leak is the leak thread object. Okay, so that's basically what we just saw here. Okay, so when you click this start leaking, this code, this thread will be run. Okay, inside the thread, you are basically in a loop in which you are just allocating the float and double array object, and you're adding to the map, and eventually it will cause memory leak. Okay, so that is the idea. Okay, so and then we are going to actually profile. So you're going to actually right click and profile. And then you are going to select memory. As a default, it will select memory. Okay, and you are going to see two different options. One is a quick, and the other one is the advanced. Okay, so this is the sample, and this is the instrumentation. So you're going to just choose the default, and we are going to record full object cycle, and we also record stack trace for locations. So these are in fact pretty heavy duty. Overhead is pretty high. Okay, but we just want to actually see how memory is actually being allocated. So we're going to actually collect all the information. If you want to take a look at the what these options are, if you click the help. Okay, so basically, if you go to right click and profile and memory selected, and if you click help, you can see information about the quick and advanced. So this is for sampling, and this is for instrumentation. Okay, all right, and you can actually see other informations as well. Okay, and then we're gonna run it. Okay. And then, when you run it, you are going to see you are going to actually have this browser popping up. Okay, so it is running as the regular application, but it's being profiled. Okay, so when you start leaking, you are going to actually see the live result. Okay, so let me actually show you. So we are going to run it. Okay, and you should see the live result. Okay, for now, things are not really, doing anything much. And by the way, you want to actually the click generation count so that you can actually see generation count in the order. So now we are going to actually run the application. So let's see here. This is, we are going to start leaking. So now when you start leaking, you are going to see you're going to see generation count is being updated, and you are going to eventually see the float and double. So if you give here, you can see the float and double right here, right? These two objects, the generation count of these two objects will be the popping up. Is going to, eventually it will go up here. Okay. Okay, so let's actually give a few seconds, and in the meantime, let me just to show you what's happening using the lab documentation. So eventually, you are going to see this double and float is on the top, and also the map entry as well, because whenever you're adding this double and, you're basically adding as the map entry, so you will see this one as well over here. So if you want to find out where this double and float objects are being being allocated, that's where you want to actually find, that's where the memory leak is happening. Okay, so you right click it and you take take a snapshot and show allocation stack trace. Okay, so basically, let's actually try that. So you can see now it's actually pretty much at the top. So right click it and take a snapshot and show allocation stack trace. So it will show you all the places where this double array object is being allocated. Okay, so in our simple application, we have only a single place where this is, where actually in fact the two places where these two the double array object is being allocated. One is the this code. As you can see, the generation count of this one is 1, but this one is 107. So this, you can see, this is where memory leak is happening. So if you take a look at the code, you go to the source, and you can actually see this method where the things are being allocated. Okay, so this float object and double object that's are being allocated. Okay, and then I can stop the profiling. Okay. All right, so that's what we have done. I want you to modify this application with a custom class. So you're going to create the Java class. So in this case, we are going to create a person class. And you just have this very simple person class, which has name property and get and set a method person. Okay. And then you're going to actually modify the code so that instead of the double array, you're going to actually use a person array. Okay. In this case, it doesn't even have to be an array. Okay. So the reason we are actually using array is because we are using primitive type so that you can actually have this as an array object. Okay. But person, because it's an object itself, you don't have to have an array like this. You can just have a person. Okay. But just to be consistent with the existing code, we're going to just use a person array like this. And instead of actually allocating double array object, we are allocating person array object of 1. And if you perform the profiling again, okay, and again you start looking, and eventually you are going to see this person array object generation count is keep increasing. Okay, and again you can take a look at the code. You can go to the source and you should be able to find where that person array object is being allocated. Okay. All right, so I am going to give exercise 2 is actually real life situations where NetBeans memory profiler is used to detect the memory leak. In fact, this exercise is based on the actual, so basically this is actually for HTTP unit. So there's a guy named Andres Gonzalez in Spain. He used the NetBeans profiler to find out where the memory leak is happening when he's testing his web application. What he has found was that he was running his application for several days, and after several days, things are not good, meaning out-of-memory exception occur. So he used the NetBeans profiler to detect it. Okay. So what is happening is that this is, by the way, is old version of HTTP unit. Okay, so new version of HTTP unit certainly actually fixed this problem. So old version of HTTP unit has a problem of when the request is sent to the HTTP unit, if there is a problem when if the response includes a JavaScript, it didn't handle it correctly. So it's basically adding an exception message to a map. Okay, so eventually that message is not it just keep adding to the message map. So eventually it will cause the out-of-memory exception. So the amount of the memory that is being leaking is very small, but so he was actually running for 3 days, 3 or 4 days to get to this problem, to experience out-of-memory problem. Okay, so this exercise is actually simulating his environment. Okay. So this is a standalone Java application which contains HTTP unit. Okay, so we are going to run this application. So memory leak HTTP unit. Okay, so I have already opened that application. So this is the one. Okay, so if you we are going to just profile, and again we are going to use the same scheme and run. And it's basically, this is sending HTTP request to HTTP, the unit server. So you can see these are the counts. Okay, so these are the number of requests that was sent to the server. Okay, and again, we are going to see the live result. Okay, and again, we'd like to see the generations. Okay, and eventually you are going to see the string or character array. So basically character array is actually string is actually converted into character array. So character array and the string will have pretty large number of generations. Okay, so let's go back to the lab documentation. By the way, this is actually the project properties is set to the maximum 8 megabytes. So this is to induce the problem a bit, earlier. Okay, so instead of using the default the heap size, we are going to use just the 8 megabytes. Okay, so it is already set up for you. Okay, so now we are running a profile. Okay, so we just use the same setup, same settings. And you can see the request in this case. This is the request number. And then we are displaying. By the way, you can also actually take a look at telemetry, telemetry overview. So if you click this guy, you can see a bunch of information. Okay, like a heap size, use the heap, and things like that. Okay. All right, so now mostly we want to actually find out what's going on. So we want to actually see allocation as well as generation. So we've been actually using generation count to find the what's going on in terms of the memory leak is happening or not. We also like to see allocation as well. Allocation also give you a sense of which object is actually allocating the most. Okay, so if you go back here, we can take a look at the generation count as well as allocation. Okay, so you can see character and string, these two guys are, in fact, the allocating large amounts of data. Okay, so here again, we like to actually see, take a snapshot and show allocation stack traces. Okay, so this is where the string object gets allocated. Okay, so here again, depending on, you can see the allocation and generation count. Okay, and we can see, let's actually take a look at the generation count here. Okay, so 29, and yeah, so this is where all the these are all the places the string object gets allocated. Okay, and you can see this one as a generation count 29. So while others are actually kind of small, so you can see this is the one that is actually being the string is allocated. Again, if you just drill down, you can see this is the one that has a problem. Okay, so if you take a look at the this guy, this is where the handle the script exception. So you can see the struct trace here, and you can take a look at the source code. Go to the source, and this is where the error message is being added to error messages array. Okay, so this is actually whenever exception occurs, this error message is being added to this array. So that's where things are actually being added without the garbage collection. Okay. Okay, so that is pretty much the exercise 2. Okay, so I showed you. You can certainly take a look at the more documentation. You can actually find more information in the documentation. Okay, all right, and you can take a look at, you can correct this one and see what happens. Okay, all right, so I'm gonna give you guys another I'll give you about 12 or 15 minutes depending on how you guys actually moving forward. Okay, next topic is heap worker. So what does heap worker do? It basically reads heap dump file, and it provides complete picture of the objects on the heap and the references between the objects. So it's useful to find out where out of memory exception have occurred. There are few concepts that we are going to learn in this exercise, and one of the concepts is find nearest GC root. So this, from any object, you can find out the nearest GC root. It will help you track down the cause of memory leaks by showing the owner of references that prevents an object from being garbage collected. So if a particular object is not being garbage collected, then you can find out who's actually referencing that particular object, and you can go all the way to the root, GC root. So GC roots are basically objects that never get removed from the heap. Okay, so you can think of it that they are starting point of JVMs, Java Virtual Machines garbage collector. So any object that's reachable from GC root cannot be removed from the heap. Okay, all right. All right, so we're going to take a look at the exercise 3. So in this application, we are going to run the application that will cause auto memory exception. So this is basically computing a prime number. So I'm going to just go to the exercise, top of the exercise. So that is what is called the memory leak prime number project. Okay, and when you actually see the let me actually show you project and prime number. So if you take a look at the project properties, if you click run, you can see the VM options is set with the 6 megabytes. So again, this is set to smaller size of the heap so that we can actually get the problem a bit earlier. Okay, I want to actually, it looks like there is a profiling still going on. So let me just stop this guy. Okay, all right. And what we want to do is when you run this application, okay, so when you run the application, we can actually just profile the application, and we are going to memory and run it. You can see, oh, it actually created a heap dump right away, which is not what we want. I don't want to. Yeah, so I'm going to just delete this guy. Okay, so let's actually go over. So we just take a look at this guy, and we are going to profile. And so we can actually monitor rather than the memory. So monitor and run. And when you run the application, we are going to try different numbers. So 10,000. So basically we want to find out the prime number of 100,000, 200,000, 300,000 until you are experiencing out of memory exception. Okay. All right. So that's what we're going to do. Project and prime number and profile. Yeah. So we're going to start the new one and monitor. Okay, and run. So here you are going to start with the number of 100,000 first. So try to compute the prime number on the 100,000. So calculate the prime number. So it came up with this number 99991. So everything is good. Okay. So now we're going to try the next one. So this is again trying to find the memory leak. The situations. So calculate. So this one works as well. Now let's try 300,000 like this. Calculate number. Now we have auto memory exception right here. So the when things are being profiled in NetBeans, it will create a heap dump. So we're gonna say yes. Okay. So once you say yes, you are going to see NetBeans heap worker is now displaying information about that. It's actually analyzing that heap dump. Okay. So you can see summary and you can see classes. So if you take a look at the classes, okay. So let me just increase. Let me actually maximize this guy. You can see. Let's actually see the size. So if you take a look at the size over here, you can see this int is the one that is taking the largest amount of memory space here. Okay, so you can actually take a look at this guy. Now you can actually take a look at the contents of this int array. So if you take a look at the int array over here, like a fields, you can see the contents of it 2, 3, 5, 7, and things like that. by taking a look at the contents of this array, they are not being garbage collected, you can actually make a guess that, the reasonable guess that somehow the prime number starting from 2, 3, 5, 7, these are not being garbage collected somehow. Okay, I mean, obviously this is not the best way to find out what's happening, but by taking a look at the contents of it, you could sometimes make a reasonable guess on what's happening. Okay. Now, what we want to do at this point is actually to find out why these objects are not being garbage collected. So one way to do that is to find out the nearest to GC root. So if you right-click this guy, this is the int array object, and you can actually take a look at nearest to GC root. So show nearest to GC root, and you can see this complete in Java frame. So basically, this complete the result. This is where this is the one that is actually causing this array to be referenced. Okay, so you can actually take a look at the source of this guy. So if you take a look at this source, you can see this is this complete result. Okay, so this is the one that gets allocated, and this is the one that is referencing this int array. Okay, so you can find out where this complete result is being used. You want to actually find out where this int array is being added. Okay, so you can right click it, and you can actually find out usages, find usages. If you go to usages, okay, and in the open project, you can find out this is where this int array is being added. Okay. So this is basically the exercise. Okay, so we did this. So start from the 100,000, 200,000, 300,000 until you get this out of memory exception. Okay, so yeah, we're gonna just stop for now. Okay, and so this is the overview, and then we go to the classes, and then we are going to display instance view. So if you double click, or you can right click and select the instance view, and we take a look at the all int array, and we actually take a look at the contents of those, right? Contents of those. Okay, and so you can see these seems like it's actually the prime numbers starting from 2, 3, 5, 7, but those are not somehow garbage collected. Okay, and you can see the nearest to GC root. So this is the complete result, and then we go to sources, and then we find usages, and then we find where this is being used. Okay, and this is the code that is actually being added. Whenever this code is being executed, somehow the int array is being increased. Okay. And the next one is take and load heap dump. So basically, the NetBeans can read heap dump file. Okay, so since you have not created a heap dump file, you don't have anything to read. Okay, but you can actually let's see, load heap dump. Okay, so if you happen to have any heap dump file, you can actually load it. You can analyze it as well. Okay. Okay, so basically. Oh, so in this case, yeah, we can actually save. You can. Oh, so you can actually take a look at the where it is actually being heap dump file was created. So here you can see with the heap dump file. This is the one. Okay, so if you go to the summary, and so this is the heap dump file that was actually created. Okay, so you might want to actually copy this file to another place, then you can actually read it. Okay, just for the sake of this exercise, that's basically what we are doing here. Okay, unless you have a heap dump file that you have created before, which you probably don't. Okay, so load heap dump file, and then it's actually reading the heap dump file from my dump directory. Okay, all right. So I'm going to give you guys about the 15 minutes to this exercise, and let's have 10 minutes break as well. So we will be back 5 minutes after 11. Last topic is dynamic attach. So with the JDK 6 and later version, you can attach a profiler to an application that is already running. So no special JVM command line flags are necessary when you start and target the application. By the way, this target application, this applies only when you are attaching application that is running on the same machine. However, if you are attaching to an application that is running on the remote machine, then you have to do a bit more the configuration. It's useful for profiling production applications. So if you happen to have running some application, and if that application is not behaving as expected, then you can run NetBeans profiler to attach to it, and it's called the dynamic attach. All right, so that is the last exercise. So let's go to the last exercise. So basically, we are going to simulate externally running application. So basically, we're going to actually create a Java application that comes with a NetBeans. So NetBeans comes with a bunch of sample applications. So here we are going to create anagram game application. So you're going to create a brand new project. So new project. So let me just show you how to do it. So you're going to create a new project. And you just go down under categories and expand samples. Once you expand samples, select Java and select anagram application and click next. Okay. I have already created anagram application. So what you want to do is you want to create a Java file so that you can actually run it on this one as a command line. So that's going to be an application that is running outside of NetBeans. So right click it and clean and build. So basically it will create a Java file for you. So at the end you are going to see this Java file has been created. Okay, and you can run that application by copying this command. So I'm going to copy this command and I am going to open the command terminal window, and you just run it. And then you are seeing anagram application is running. So just guess, new word, whatever. Okay. So now we have externally running application. So this is not running inside NetBeans. It's running outside because we run it on the command line. Meaning there are two different. NetBeans is running its own JVM, and this one is running on its own JVM. So they are separate JVMs. Okay. So what we want to do is we want to attach NetBeans profiler. So let's actually go back to the lab documentation. So this is what we just did. Yeah, basically making sure you're using JDK 6 and above. So I'm using 7, and we did a clean build, and so we have this command. This anagram job file is created, and we just run it. Okay, so that's what we have done so far. Now you are going to attach NetBeans profiler. So you click profile and attach profiler. Okay, and then you are going to select external application. Okay. And here we're going to actually try the memory, profiler. Okay, so external application attach. And then you are going to have these configuration options. So target could be local or remote, and the connection could be dynamic or direct. So here we're going to actually use dynamic. So it's connect to already running Java 6+ process. Okay. Direct. If you happen to have a Java 5 application, you can use this guy. Okay, but that application has to start with some kind of flag. Okay, you can select remote. Okay, that is attaching to remotely running Java process. Okay, so here you select the anagram process, and then you're going to see profile agent is actually being displayed like this. Okay, so let's actually do it, and you're going to actually do it as an exercise. So we are going to select profile and attach profiler. So we are going to attach to the anagram application here. Okay, and we are going to use a memory. Okay, advanced, and we are going to attach. So we are going to have these options. So we are attaching to locally running Java process, and we are using dynamic, meaning existing application does not have to be started with some kind of flag. This one is for Java 5. Okay. Now, if you click the remote, okay, it actually gives you step by step for the attaching remote process. So in this case, make sure target application is configured using Java 6 Plus. Okay. And if you have not done yet, create the so you have to create remote profiling pack, and that profiling pack has to be run with the remote application. So that is a little bit more involved when you are attaching remote process. Okay, so here we are going to actually try local target, and we are running dynamic connection. So remember, in this case, I didn't. We are actually touching the application that is already running without any kind of flag. Okay, and click OK. Now, and select process. We're going to actually select this anagram process and OK. Now, you can see here this is the command line where I'm running the anagram application. So you can see, profiler is actually being attached. Okay. Now you can see, so we can run this application, new word, and things like that. Now we are going to take a look at the live result. So live result. So basically, this is actually what's happening right now. Oh, wait a minute. Yeah, so this is live. Okay, so yeah, so this is what's happening. So let's actually see whether things actually. Yeah, okay, so things are changing. So I'm gonna just type guess. Yeah, so it's actually being updated from the remote process. Okay. And if you're not disconnected, here, this is if you move your cursor over here, it will disconnect your profiler to your remotely running process. Okay, so if I click this guy, and do you want to terminate the profile application upon detach? So if you click yes, then application will be stopped. If you say no, the application is going to still run. So for the sake of exercise, I'm going to just click yes, and then application stopped. Okay. All right, so that is the exercise 4. So I'm going to give you guys about 12 minutes to do this exercise.